The next resource we will look at in this bonus performance module is memory, and specifically NUMA. If you open a dual socket server, you'll usually find that the memory sockets are in groups that flank the CPU sockets. This isn't a coincidence. The memory slots are connected directly to one of the CPUs, and there is a system bus that interconnects them both. Modern operating systems understand this, and when a thread needs to execute against data stored in memory, the operating system will try to allocate that thread to the CPU that is connected directly to the relevant module. This is called NUMA, Non-Uniform Memory Access, and these groupings are called NUMA nodes. So let's look at how VMware uses NUMA to optimize performance on your VMs. At the simplest level, VMware will automatically allocate resources so a VM's memory is stored within a single NUMA node, and its CPUs are scheduled on a processor within the same NUMA node. But what about bigger VMs, which cannot fit into a single NUMA node? In this example, we have 4 quad-core CPUs in our host, and a VM with 8 CPUs assigned to it. Of course, we cannot fit all 8 cores into a single NUMA node, so VMware activates vNUMA. vNUMA exposes the NUMA nodes to the virtual machine's operating system, dividing the CPUs and memory and scheduling the resources as appropriate. vNUMA is enabled automatically on VMs with 8 or more cores, and for the most part it manages itself. But there are times when you may need to intervene, such as in the case of so-called wide VMs. In this example, we have 2 quad-core CPUs and 32 GB of RAM, split across the 2 NUMA nodes. Our VM only has 4 CPU cores configured, so vNUMA will not be enabled by default, but the 20 GB of RAM will not fit into a single NUMA node. If the application in this VM is memory intensive, you can reduce latency and improve performance by manually enabling vNUMA on this VM. That requires adding a manual entry on the advanced settings portion of the VM's configuration and is well beyond the scope of the VMware Certified Professional exam. Beyond this, there are a few ways you can make vSphere's job easier. Firstly, stick to the rule of multiples, like we discussed in the CPU Ready lecture. Imagine your system has 4 NUMA nodes and you assign 10 cores to one VM. vNUMA will attempt to divide the 10 cores by 4 to align with the 4 NUMA nodes, but of course this is not possible. Additionally, if you change the number of sockets in the VM's settings, make sure that you apply the rule of multiples to that too. What we have learned between this and the last video are relevant to all hypervisors, including Hyper-V. The terminology is different, but the fundamentals are the same. If you've ever looked at cloud platforms like Azure and AWS, you'll have noticed that most of them force you to select from specific combinations of CPU and RAM, instead of allowing you to customize the specs to your requirements. This is because Microsoft and Amazon have designed these instance sizes to ensure their platforms are as efficient as possible.